Hi everybody, today we're going to start section 4.5. We're going to use solving systems using inverse matrices. Not a lot different than what we were doing before, except how we set up the problem. So now instead of us having that capital X to find that matrix, what we're going to do is we're going to give you a system of equations, and you guys will be in charge of setting it up and solving from there. So slight variation. First thing we're going to do today, we want to write the system of linear equations as a matrix equation. Pay attention to directions. If I tell you just write the system as a matrix equation, you do not need to solve it. All we need to do is we are going to set it up. This is going to be a lot like what we did with Kramer's rule. We're going to take all of our coefficients and we're going to make those into a coefficient matrix. So, -3, 4, 2, -1, just like we did with Kramer's rule. Then, to get our variables in there, well, x and y. You're going to want that column matrix because when you multiply these together, you will end up getting the same equations out. So I know it seems weird that both of them have an x and a y, but again, remember, when we multiply those together, we should get the same things on the left and on the right. Since we have two separate equations, we're saying that the top equation is going to be equal to 5. The bottom equation is equal to -10. Okay, really that is the big difference between what we are doing today and what we did yesterday. So just changing that capital letter X and starting with this. Now we've got to set it up and we'll have an X and a Y, but it doesn't really matter. So I will show you how we're going to do these here in a second. So you can think of this as your A, B, and if you want, this X matrix would be that X from yesterday. So look at this, same equations. Now we're going to use matrices to solve the linear system. So this is how I'm going to tell you that you are going to use that linear equation. Again, this is just a different way to solve these equations. So we need to turn these into a matrix equation. So same thing we just did, -3, 4, 2, -1, xy is equal to 5 and -10. Set up that equation there. And we start working almost exactly the same way that we did with the last video. So we need to find the determinant of A. Remember, this is my A, this is my B. So I'm going to take -3 times -1 minus 2 times 4. So I am working to find the inverse of A. So I'm going to get 3 minus 6, or 8 if you can multiply correctly. Seems to be my style these days. So you're going to end up with -5 is as that matrix, or as that determinant. Okay, now to find my inverse, 2 by 2, so I have -1/5. So I just moved that negative out front, means the same thing. And I'm going to multiply that by A. I've got to flip my main diagonal, -1 and 3, and change the signs on my other diagonal, so I get -4 and -2. And I multiply through by that negative 1/5, so I get 1/5, 2/5, 4/5, and because those are all negative and this 3 is positive, I'm going to get a negative 3/5. So there's my inverse of A. So I would multiply that by that on the left. I would get my identity by the left of what I have in the blue. So I'm going to multiply by the left on the right-hand side. So I end up with, on the left, when I multiply by that inverse, I'm going to end up with just my XY matrix, that column there, and I'm going to get, move this down a little bit. I'm going to get 1/5, 2/5, 4/5, and negative 3/5 times 5 and negative 10. And we just go through our matrix multiplication now. So I'm going to move this 5 and this negative 10 up top. I multiply down my columns and add the two columns together. So I'm going to get 1/5 times 5 and 2/5 times 5 plus 4/5 times negative 10 and plus a negative 3/5 times a negative 10. Which is going to give me 1/5 times 5 is 1 plus 4/5 times negative 10 is going to give me a negative 8. 2/5 times 5 is going to leave me with 2, and negative 3/5 times a negative 10 is going to leave me with a positive 6. So you guys probably already know this. Obviously, I forgot my negative on my 3. So this negative 3/5 should be positive. So I'll go back, touch those up real quick. Plus 3/5 times negative 10. And this should be plus a negative 6 now. Okay, so sorry about that. As you guys can see, I make mistakes, especially with negatives. So when I simplify this down, I get the matrix of 1 plus negative 8 is going to give me negative 7. 2 plus negative 6 is going to give me a negative 4. And since this was still on the left side, my xy is equal to that. So my final answer, if you remember anything about our equal matrices, the two corresponding parts have to be equal. So x has to be negative 7. Y is going to be negative 4. And my final answer in an ordered pair, negative 7, negative 4. That's what I'm looking for. So one more example for us to work through. So write as a matrix equation and solve. So again, use your matrix equation. So set up our coefficient matrix: 8, 14, negative 6, negative 7 times xy is equal to 4, negative 10. Again, my matrix, my coefficient matrix is A. What it's equal to is B. And I'm trying to solve for X and Y. Again, first thing we want to do is we want to find, go up here, find my determinant of A. So I'm going to get 8 times -7 minus -6 times 14, which is going to give me, when I simplify everything down, I'm going to get a positive 28. So the inverse of A is going to be 1 over 28. Don't everybody freak out yet. I know that looks awful. And then I flip my diagonals, my main diagonal, so I get negative, this is still matrix, so I get -7 and 8 here, and I go 6 and 14 have to change signs, so I get -14 and a +6. And when I multiply that all out, I end up with, and I'm going to leave my fractions unreduced because I know what's coming next. You guys will see why I want to keep these as with that common denominator already, because when we multiply, we're going to have to add. So I'm going to end up with -7 over 28, 6 over 28, -14 over 28, and 8 over 28. All right, hopefully I haven't missed any negative signs again, so we can keep working here. So I know that when I multiply, I end up on the left with xy. And that's going to equal my matrix of -7 over 28, 6 over 28, -14 28ths, and 8 28ths. And I need to multiply that by 4 and -10. So multiply, move my column over. I'm going to go 4 and 10. So I'm going to end up with -7 over 28 times 4, 6 over 28 times 4, plus -14 over 28 times 10, and plus 8 28ths times 10. That's going to give me -7 28ths times 4 is going to leave me with a -1, plus -14 28ths times 10 is going to leave me with a negative. There's my lost negative. So this should be a -10. So this should be add a +5. Then multiplying the bottom, just to make things a little easier, I'm going to leave these as 24 28ths plus a -80 28ths. So I know that xy is equal to 4 and 24/28 plus negative 80/28 actually turns out to be a nice number of negative 2. So that means that my answer is going to be 4, negative 2. And that's what our answer should look like. So let me know if you guys have questions. We'll practice more in class, and I will see you guys later.